Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. This is the start of a series we're doing before the exams, and we are going to be, inshallah, doing some questions for each one of the units that we're covering for the exams. Okay, so what I'd like you to do is please bring your calculator and your paper, and please try and do these questions with me as I go along. Okay, so just a word before we start. First of all, just a quick word. So these videos are supplementary to your own study. So what that means is they don't replace the book, they don't replace your own notes, they don't replace any material that the teacher has given you. In my case, the booklets. Okay? Your book and your notes are the main source of study. If you need extra help understanding the chapters, please watch the original unit video lesson. So what that means is if you want to watch, for example, if you want some in-depth explanation of Unit 5.1, just watch the video on Unit 5.1, which I will be putting in the link in the description below the video. Thank you. Okay, so let's go. So this should be quite short. The point of these videos is just quick practice. I don't want to make them too boring, so they should be about 15 to 20 minutes long, maybe even less. Let's go. So this is from the revision pack. I'm going to attempt to answer this one first before I give you some more questions. If the force acting on an object doubles, what happens to the object's acceleration? If the mass of an object doubles, what happens to the object's acceleration? So the easiest way to do these questions is by simply picking some numbers at random and putting them in. Okay, so pick some numbers, put them into the formula and see what happens. So the formula says force equals mass multiplied by acceleration. So this is, remember this is question one. So if I go with some numbers here, so if the mass is 1 kilogram and the acceleration is 2, then the force is going to be 2 newtons, right? So the first question says, what happens if the force acting on an object doubles? What happens to the acceleration? So of course the mass of the object stays the same, but we are now doubling the force. So what's going to happen to the acceleration? Well, 1 times 2 does not equal 4. It equals 2. But now, if we double the force, we are going to double the acceleration, aren't we? That's the only way that makes sense. So, what happens if we double the force? We double the acceleration. What happens if we halve the force? We halve the acceleration. That's how we answer that one there. So that's part A. What about part B, where it says, if the mass of an object doubles, what happens to the object's acceleration? Okay, well, let's have a look. So, assuming the force stays the same this time, so the force stays the same, let's keep it at 4 newtons, and the mass goes from 1 to 2 kilograms, what happens to the acceleration? Of course, it's going to halve. So that is the answer for question 1. Part B. If the mass is doubled, the object's acceleration is halved. And that makes sense, just generally speaking, thinking about it. If an object is double the mass, then it's going to be harder to accelerate it, isn't it? Okay, and the acceleration is going to be half of the acceleration of a lighter object. Okay, so that's as far as question 1 is concerned. If we double the mass, we have the acceleration. If we double the force, then we double the acceleration. The other way to think about it is if you think of a ball, for example, if you kick the ball, then you got to give it some acceleration. If you kick it twice as hard, then you're doubling the force, twice as hard. That's what we mean by doubling the force. You're kicking it twice as hard, then it's going to accelerate twice as much. Okay? That's what that means. Question 2, Question 2, what net force must act on a 540 kilogram golf cart to give it an acceleration of 2.5 meters per second? Once again, force equals mass times acceleration. This is going to be your best friend, this formula. Doing anything to do with Unit 5, Newton's laws of motion, this is your best friend right here. So we have the mass, and we have the acceleration. What's going to be the force? The force is going to be mass times acceleration, which is approximately 1,200. 540 multiplied by 2.5, so 1,350. Okay, and what's the unit? Newtons. Okay, so here's the way you answer an exam question. Okay, just for those of you that are not sure. The way to answer an exam question is look for those 4. We always look for 4 things when we're marking. We always look for 4 things. What are they? Formula, workout, answer, units. Okay, let me repeat that. Formula, workout, answer, units. So please make sure that you, first of all, you write the formula, because that way, even if you get it wrong, we can give you some of the mark. You do the workout. Of course, we want to see the workout. We want to see the answer, and we want to see the correct units. That's how you make sure you get the full marks. Okay, so that was question 2. Let's go to question 3 now. Question 3 says, a 1,800 kilogram truck pulls a 620 kilogram trailer from the stoplight, so that means from 0, and accelerates at this much. What is the force exerted by the truck on the trailer? Now, this is a bit of a trick question because it doesn't really matter what the mass of the truck is. It's like saying if I'm pulling a car, or if I'm pulling an object, or if I'm pushing a box, does it matter what my mass is? No. What matters is the box, right? So here, so that really doesn't matter. I have a trailer, and the mass of the trailer is 620 kilograms, and the acceleration of the trailer is 1.16 meters per second squared. And once again, we need our best friend here. And so it's going to be, that's the formula. Okay, this is the known and the unknown. So what's the unknown? I don't know what the force is. Here's the workout. Mass times acceleration, 620. F equals 620 times 1.16. And that will give me the acceleration, the force, excuse me, which will be 719.2. Now we are working with two significant figures, so 720 newtons. Okay, and that's how you do that one. Hopefully not too hard. Excuse me while I take all of this off. Okay. And of course, just want to say something here. If you prefer working with triangles, I like working with triangles. So you can always write the triangle form, and that way you can cover what you want. Because obviously in the exam, you will always be given 2 and be asked for the third. Okay, so you might be given acceleration and force and be asked to work out the mass, or you might be given mass and acceleration as the example now, or you might be given force and acceleration or force and mass and be asked to work out the acceleration. So always a good idea to work with the triangle if that's what you prefer. Okay, question 4 says, a 91 kilogram parent, this example has come to us so many times, and the 21 kilogram child, okay, are sitting in the middle of or the center of an ice rink. They place their hands together and push, so they push each other apart. Okay. Is the force experienced by the child more than, less than, or the same as the force experienced by the parents? Well, I can tell you right now, Newton's third law says for every action there's an equal and opposite reaction. The forces are equal. The forces are equal. The acceleration is not equal. The mass isn't equal, but the forces are. Okay, so force equals mass times acceleration. Now, the mass of the father is different to the mass of the child. If the masses were the same, then the forces would be equal in magnitude as well. But the masses are not the same, therefore the acceleration is not the same, even though the force is the same. Okay? And we're going to come to understand what this means. Now, is the force experienced by the father or the child, are they the same? Yes, they are the same. Now, next thing is asking, B, is the acceleration of the child more than, less than, or the same as the acceleration of the parent? Of course, the acceleration of the child is going to be more than the acceleration of the parent. Why is that? Look at the formula. Look at the formula. If the force is the same, but the mass of the child is less, then the acceleration is going to be more. Okay, let's take an example. If the force acting is 200 newtons, the mass of the child is 20 kilograms, then the acceleration of the child is going to be 10. If the force acting on the father is 200 newtons as well, but the mass of the father is 100 kilograms, then the acceleration of the father is 2. So that's common sense, isn't it? If the mass is more, the acceleration is less. Anyway, let's keep going. They've given us some numbers here. If the acceleration of the child is 0.31, so now we know that the acceleration of the child equals 0.31 meters per second squared. What is the magnitude of the father's acceleration? Okay, so just remember that they are accelerating in opposite directions to each other. So I know that force equals mass times acceleration. Remember, always start by writing the formula. And I know that the child's mass is 21, while the acceleration of the child is 0.31. That means that the force acting on the child is going to be 21 times 0.31, which is equal to 6.51 newtons. Okay? And since we are working with two significant figures, it's going to be 6.5 newtons. Now that's going to be the same as the father. Okay? So the father's force is also going to be 6.5 newtons, except I'm going to write it as negative 6.5 newtons because they're in the opposite directions. It doesn't matter which one is negative, which one's positive, as long as they are opposite each other. If one is negative, the other is positive. If one is positive, the other is negative. Okay, it doesn't matter. Do we have the mass of the father? Yes, we do. The mass of the father is 91 kilograms. You can certainly work out the acceleration, can't you? So force equals mass times acceleration, obviously. So that's force, that's mass, times acceleration. We're trying to work out the acceleration. So it's going to be negative 6.5 divided by 91. So it's going to be negative 0.07. Oh, yep, meters per second squared. Now here's the thing. I don't actually have to have the negative there because it's asking for the magnitude. You see that? So it's not even asking for the acceleration, it's asking for the magnitude of the acceleration. They're being nice. They just want the number. So that is technically correct, but really it's 0.07 is fine. Okay, let's move on. I told you I want to keep these videos short, so we're going to keep them under 20 minutes. When a bus starts suddenly, the passengers are pushed back. This is an example of what? The passengers are sitting down, okay, they're not moving, they don't want to move, their bodies don't want to move. The bus forces them to move. This is Newton's first law, the law of laziness, the law of inertia, the law of stubbornness. Objects that don't move don't want to move, objects that are moving don't want to stop, okay? And so the passengers are not moving, they don't want to move, the bus forces them to move. What's going to happen? They're going to move back because they want to stay in their position. Okay, so this is first law, also known as the law of inertia. My apologies. I am planning on getting a new Surface Pro, which will make the writing experience so much better. So I'm just waiting for a while. Right, let's move on. A feather of mass 15 grams is dropped from a height. It is found to fall with a constant velocity. What is the net force acting on it? Interesting. Here's a feather. It is falling. Okay, and here's the ground. Okay, so it's falling to the ground, and we're being asked to calculate the net force acting on it. So here's the thing. It's a trick question. Why? If it was just falling, simply falling, then we know the acceleration towards gravity. Well, force equals mass times acceleration, and the acceleration towards gravity is 9.81. But it's telling us it's falling at constant velocity, which means there is no acceleration, or acceleration of zero. If the acceleration is zero, it doesn't matter what the mass is, what's going to be the force. The force is going to be zero, okay? So that's simply it. So it's going to be force equals mass times acceleration. And since it doesn't matter what the mass is 0.015, but since the acceleration is zero, then the force is equal to zero. Okay, that's why. Constant velocity, no force acting on it because there's no acceleration. Next, here's a question that requires a little bit of work, but it's basically as hard as they come when it comes to 5.1 or talking about Force equals mass times acceleration. Let's have a look. A 1-ton car accelerates from a complete stop. That should say from a complete stop. Okay, from a complete stop to 60 kilometers per hour in 10 seconds. What force is applied by the engine to move the car? Don't panic. The first thing to do is to look at what you have. You have the mass, 1.2 tons. Do you have the acceleration? Well, you can work it out. The acceleration is change in velocity over time, which means 60 kilometers minus 0 over time. And we can work out the force by the engine. Just a couple of steps before we do that, because we need to change 1.2 tons to kilograms. So a ton is 1,000 kilograms. 1.2 tons times 1,000 equals 1,200 kilograms. So that's sorted. Alhamdulillah. That's one thing out of the way. Let's look at the acceleration. How do we do the acceleration? Well, we've got the acceleration in kilometers per hour. So what do we need to do? Change it from kilometers per hour to meters per second. So 60 kilometers per hour, which is 60 times 1,000, because it's 60,000 meters, divided by 3,600, which is, okay, do you want me to do the conversion? I'll do the conversion. 60 kilometers is equal to 60,000 meters divided by per hour. So in an hour, how many seconds in an hour? We've got 60 minutes. Each minute has 60 seconds. So it's 60 times 60, which is 3,600, which is equal to 60,000 divided by 3,600. So it's equal to 16.7 meters per second. That's the final velocity. Minus 0 divided by 10, that's going to give us the acceleration. So we've just worked out 60 kilometers per hour is equal to 16.7. So instead of writing 60 minus 0, I'm going to write 16.7 minus 0 divided by the time. What's the time? 10 seconds. So that's going to give me the acceleration. Okay, sorry, if I was moving a bit too fast, please pause the video, go back, look through it. It's just that I want to keep the video short. So minus 0 divided by 10, and that's going to give me an acceleration of 1.7 meters per second squared. Now that I have the mass and the acceleration, I can work out the force. (1,200) times 1.67. Now, here's the thing though. When I'm doing my workout, I don't actually use 1.7. I don't round till the very end, and that's to avoid errors, okay? So I'm actually using 1.67, 1.66666, okay? And when I'm doing my workout, when I'm doing my calculations, it's essential that you do the same thing. That way you don't actually carry forward any error. Because in the end, once you do it properly, you actually get a nice round number, 2,000 newtons. That's how much force the engine needs to apply. Okay, I hope you enjoyed that. I'll see you in the next one. Adios.